So with 30 seconds to go, Justice and Greg, welcome. I will pass it over to you guys. Take it away.
Thank you very much, Simon. Welcome, everybody. This is time for us to give some feedback again on the anti-financial crime and risk management solution that we've been working on, named Actio. As you know, this is an open source initiative. A little bit of just a catch up of where we've been to date for new members of the audience who may not have seen our presentation in the past, but we started now approximately almost exactly a year ago with a proof of concept where we did our initial build of the architecture, and during that time mostly focused on could we achieve the performance by compiling a open source software solution for fraud risk management. And we test drove that across 5 different typologies, and we achieved at 8,000 transactions per second in our performance with a 35 millisecond turnaround time. And then from there, we started to work on our MVP solution, which was then gradually adding more components to it. We built our pipeline and our data infrastructure. We attached a number of our components, and over time, over the last few months, we have now, here we go, our final PI, which is well, not our final PI, but our current PI, which is PI 4, coinciding with the Mojulu PI 15. The things that we had developed over the last 3 months, this has been a very challenging PI for us, and you'll see in a minute when we talk about some of the security concerns we'd uncovered. We had to change our timetable a little bit to address some security challenges in our platform and our architecture earlier than we expected that we needed to. That was largely because of some vulnerabilities that we uncovered that exposed us to a Mozzie botnet infection. We'll be talking to you about that in some detail a little bit later. But we were able to complete our end-to-end flow now, which is all of the processes that we need in order to be able to evaluate a transaction for fraud. I'll show you a little bit about what that flow looks like. And then we started off with a specific ISO 20022 implementation where we took the ISO messaging, which is typically an XML standard, and converted that into a JSON formatted message. Our initial delivery of that message and the format for our first message, which is the pane 001 message, didn't replicate very well. So we went back to the drawing board in this PI and refactored that message to come up with a slightly more standardized and a compact JSON format, which we can also show you. Our inter-service communication previously that we had used, if you remember from our previous PI, was gRPC. But gRPC turned out to be incompatible with one of our other components, which was OpenFARS. We couldn't realize some of OpenFARS's benefits around the automated and hyperscaling. So we rolled back gRPC for now and just replaced it with a HTTP interconnection messaging protocol. And then we have also added a lot more functionality in our testing. So previously our testing using Postman evaluated a response message, and it was largely to make sure that the message was received properly, and then that the component that was doing the work fed back a message that says everything was okay. But we didn't have a lot of insight into whether or not that component was actually doing what it was designed. So who watches the watcher? So we enhanced our testing process a little bit to be able to not only test largely the connectivity and the result of a specific process, but also the functionality itself. That I think was good for us to move our automated testing and our CI/CD forward. That in an overview is what we achieved in this PI, but please don't leave yet. We're going to get into the detail now. The location of our platform overall is we receive messages out of a Mojulu instance, would be quote messages or transfer messages. And then those messages arrive as ISO 20022 messages into our platform, where we do our data preparation, and then subsequently the transaction evaluation based on that data preparation. In our previous PI, we had delivered pseudonymization in the data preparation stage to properly secure the data. And then at the end of this process, we will then egress an alert to a potential case management and investigation platform, where you can then see what the outcome of that process was. The alert should also feed back to the source system, so that if you choose to react to that alert immediately and maybe suspend processing for a specific transaction, or for a client, or for an agent, or whatever the case may be, you can do that. We looked at a number of different configurations, and the configuration that we picked for our initial deployment for our MVP is a semi-attached model, which means that you would have a fraud risk management solution that provides fraud risk management services to a hub operation such as Mojaloop, but also equally can receive direct transactions from a number of associated DFSPs with a hub, or even independent DFSPs, so that you could have a more holistic picture of fraud in your ecosystem. One of the biggest challenges that we've always had is on-us transactions that are only within the boundaries of a single DFSP are not visible to the fraud risk management solution. So this allows us to open up our interface to accept transactions even for an on-us transaction, or a DFSPs that are transacting directly with each other through existing point-to-point agreements. So our process flow, we start off with, because our system accepts ISO 20022 messaging, we expect that there would have to be some sort of payment platform adapter at the front of it that could convert your native message formats into an ISO 20022 format. That is work that we have specified and outlined, and we've taken to the design authority at the end of our previous PI, and we have approval in principle for an approach. That approach is on the table, and it's something that would need to be built in order to adapt a Mojaloop message for an ISO 20022 message for the Transaction Monitoring Service API. And then we have our TMS API itself, where we receive messages. Messages are validated against Swagger doc, and then routed to NiFi, which is our data preparation stage. In our data preparation stage, we have a number of activities that we perform on the data to prepare it for the subsequent evaluation. So one of the first things that we do is we would need to resolve the entity. So entity resolution for us means, how do we know that the person that is transacting from DFSP B may be the same person that is also transacting from DFSP A? In a Mojaloop context, that means that we utilize the personal information that we have available as part of the message and attempt to match with a high degree of certainty a specific individual or an entity across a number of different institutions. Once we've done that, we would pseudonymize all of that identifying information and hide it behind an SHA-256 HMAC encrypted pseudonym. And then we also have a step here where we can add or inject additional information into the data stream that may be relevant for the evaluations. In our initial analysis, there's actually very little enrichment that would take place here during data preparation. Enrichment is probably largely going to be injected directly into a specific rule that would need additional information. So for example, if you needed to reference a list of IP addresses, and those IP addresses are associated with a specific region or a country, you would import that list at the point where you need to evaluate it for a rule. You wouldn't necessarily attach that list up front to your entire data stream, because it may not need it at all. And we also, at this point, write the message history. This is a slight departure from original designs, where we proposed to write the message history right at the end of the process. We'd actually brought that message history step forward because we have a number of rules that actually rely on the message history already existing at the time that the rule tries to do its work. So it's important for us to write the history as soon as we possibly can, which is as soon as we have done all of our data preparation work on the message itself. We also arrange the messages into a transaction network graph. The write message history and the transaction network graph, that's work that is coming up in our next PI, so that hasn't been delivered yet, but that would be overall part of the data preparation. And then the next step in our process is our channel router and setup processor. So this is a step where it is inefficient and also unnecessary to run every rule and every typology for every transaction. If a transaction doesn't contain any foreign exchange, then it doesn't make sense to evaluate it for typologies that relate to foreign exchange. So those are, at this point, culled from the scope of the evaluation. The channel router and setup processor then routes the transaction to all of the rules that need it for its evaluations. And those rules then calculate a logical result based on the content of the message. It evaluates a number of different things, and those are then ultimately aggregated into a typology that says this combination of rules with this set of true and false results mean that there is a significant chance that this typology is in effect and that there is a high risk of fraud or money laundering involved in the transaction. And ultimately, when we do our channel routing and setup processing, we have a number of themes according to which we arrange specific typologies. So you may have fraud typologies, forex typologies, money laundering typologies. These are all arranged into segregated themes that we call channels. And once we have evaluated the typologies within those channels, we aggregate them into a channel result. This step is largely for us to be able to issue a go decision if, for example, a system is waiting for us to produce a result. So a typology may have the option to stop a transaction immediately if the typology score is high enough, but the channel router has the opportunity to say, based on the sum of a number of typologies, we are comfortable that the transaction is not a problem. You can proceed so long, but we're still going to carry on and complete the evaluations of our other typologies because it may relate to future evaluation results. And then finally, we close off the transaction completely. So here we would evaluate all of the typologies and make sure that there isn't a interrelated issue that we may want to send an alert on. But we also at this point, finally write all of the transaction results that we have determined based on our rules evaluations, our typology scoring, our channel aggregation is then combined and written away to the data store. And finally, if there is any reason for an investigation to be required, an alert would be generated into a case management solution. The case management solution in detail is not part of our scope for the MVP, but we are providing the egress point for sending an alert into a case management solution that could be attached at a future point. And then this just illustrates the channel router and setup processor over here, where all of the rules are invoked from this processor and then reconstituted into their various typologies. Typologies are constituted at the channel level, and channels are finally concluded in a transaction aggregation step.
Just before you move on, Justice, on that diagram, probably worth stating that the channel router sends to multiple rules, but it also sends to multiple channels. We have the option to send and do a lot more. So it might be worth just briefly touching on that. The reason behind that decision is so we can manage interdicting separately to one payment channel or another, and therefore we have a lot more flexibility within the architecture that allows us to scale horizontally as well as vertically.
Yeah, and in addition to that, one of the key features that we're trying to achieve here is a little bit more efficiency. So we only execute a single rule once across the platform for a specific transaction. And then a number of different typologies may at the end of the day need to access that rule's result. So the rule is called once, and then the rule result is then submitted to the typology processor, which determines which typologies then need that rule's result. So it helps us so that we don't have to execute a single rule for every typology, but rather just once for a whole transaction. And as Rob mentioned, it gives us a lot of flexibility here in how to configure the platform for a specific implementation. If you don't need interdiction, then we won't add the interdiction channel to your deployment. If you don't need money laundering for the work that you're trying to do, then all of the typologies that are located in a money laundering channel can then also just not be deployed. And the channel router and setup processor over here would have the logic and the intelligence to determine which rules to invoke, which typologies are necessary, and which channels are in scope. This was our PI4 scope at the end of the previous PI. We wanted to extend the TMS API to include the remaining ISO messages. So at the moment we built for pane 001, but there were 3 other messages that correlate to the modular processing steps that we also wanted to include. We wanted to build our entity resolution during data preparation. We wanted to do the other pseudonymization for the other messages. So once you determine the pseudonym in pane 001, you can then also do the pseudonymization in the other 3 remaining messages. And associated with that, transaction history, the graph for the network of transactions. And then largely that would bring the foundation of our platform to a close, and we could then start populating the platform with rules and typologies as content. In addition to that, rules would bring additional data to the table that we needed to include in those rules as scope for evaluation. So enrichment would have been included in that. And channel aggregation and decisioning development, and the transaction aggregation and decisioning development. And then we had a new scope. So we'll talk about that in a second. But we had to rebuild our entire infrastructure and pipeline from the ground up. And Greg will tell you a little bit more about that in the next slide. We did manage to complete the channel aggregation and decisioning development. So our end-to-end, including the transaction aggregation and decisioning development, was done. So we managed to at least get through our whole flow, and we completed that at the beginning of the PI. And then we spent probably the bulk of the PI on platform security hardening. So this was always in scope for our MVP, but we ended up having to do this a little bit sooner than we'd originally intended. So that came forward and formed the bulk of our work during the current PI. And then, as I mentioned, standardizing our ISO 20022 in a compact JSON format that we completed for the pane 001 message, and we're currently refactoring our pipeline to thread that message through. I think we only have 2 processors left for that. We've replaced gRPC with HTTP, which again is a refactor of our pipeline. So we did that in combination with the ISO 20022 work. And then finally, we enhanced our automated testing. So let me just quickly go to this slide. I'd mentioned that in an overview of the pipeline. So just briefly, what this does is it aggregates the results from all of the various channels and typologies within those channels, where we can then say, this is to get us to a point where we can issue a go, no-go decision. A go, no-go decision is usually only for when we implement interdiction, which is not something that we are specifically building for Mojaloop, but something that Actio needs to make the product viable elsewhere in the market. There are a number of places where interdiction is necessary. And then after this, there was the transaction aggregation and decisioning, which closes off the evaluation of that transaction and then also writes away the transaction results to our data store. The creating of an investigation alert, we created the egress for that, but obviously there is not yet anything on the other side of that message to pick it up. So far we are logging the alert, as it were, but there will be an interface egress that will follow in the next PI as well. And then I think, Greg, I'm going to be handing over to you for an overview of our security gardening. Thank you.
We've heard a lot about this at this point. We've definitely changed our scope. We were not thinking about hardening the system until later. But hey, I'm just going to say we got hacked, right? It's as simple as that. We're using one product in particular that is not used in Mojaloop, and we discovered that it has an awful lot of vulnerabilities in it because it's very big, and we didn't have some things locked down in it. So I feel like I have to change my voice and go into detective mode here on or about 22 June 2021, a suspicious process of a reporting. So basically, we noticed that NiFi was running a variety of things. We hadn't yet realized what was going on. We just thought maybe it was having some issues. But by the 26th of June, we realized that it was compromised. We started working on that on the 1st of September. We discovered that, frankly, it had grown to the other clusters, or the other containers in the clusters. So those were also infected. And we identified it as previously mentioned as a Mozzie botnet attack. So what we started to do was on 22 June, all the public access to NiFi was locked down and the processes that were visible were removed. But we realized the container was beyond all hope. So we destroyed that and rebuilt a new fresh container. On the first, when we realized that everything had gone to the rest of the cluster, we destroyed that and rebuilt that as well. And through this process, we realized that this is a point that I brought up in the TGB, that we all tend to reuse a lot of containers to save time. And doing that actually proved problematic for us because that's where a lot of the vulnerabilities were, and especially since we hadn't started the hardening process at this point in time. So we haven't done the full report out on this yet because frankly we were scrambling to get back on track and everything else. We'll be providing the root cause analysis and everything that happened as far as all the containers, because some of the containers where there were vulnerabilities were also containers that exist inside Moduloop as well, or we got them from there. Could you go to the next slide, Justice? So what attacked us, as we mentioned, it was a Mozzie botnet. That's a P2P botnet. It uses the DHT protocol. Basically, it looks for any kind of weakness, starting with Telnet and any other type of exploit it can go after. And it looks for any type of network devices. It's really focused primarily on IoT or video recorders and things like that, but anything that's connected, it can go after. So we pulled this graphic from the from Binary Defense, and it's just pretty much a standard process, right? So they're scanning for the internet for things, identifying the targets, exploiting the path, whatever the vulnerabilities are in that. Then they deploy Mozzie to it. At that point, it starts to enable persistence in what's going on, and then it basically spreads itself so that it will maintain persistence. It also then starts to block any remediation capability, and it deploys a specific exploit kit. So it starts to increase the target spread and basically start scaling out. So that's what really happened to the rest of the container. NiFi basically became an exploit point and then forced itself out. And normally, in a lot of circumstances, they'll demand a ransom then at that point in time in order to try to get rid of itself, to get rid of the Mozzie bot. Can you go to the next slide, please? So again, they got in through NiFi. They used basically an NiFi process to deploy a self-duplicating script. That script was then executed and provided root access to the NiFi container. And at that point, they're able to monitor all traffic as far as what's going on with that container, which is how then they find their way to the other exploits that were available within the cluster. So obviously the long-term resolution, this is something that Moduloop already had in place, but again, we did notice things that were in some Moduloop containers as well. It is the continuous container security and scanning, continuous package scanning, securing all the exposed endpoints, and we definitely know which ones are a problem now. Reviewing and altering namespace network policies and things along those lines. So basically, we just moved this up because we had to. These are all things we would have been doing anyway during the course of the project. But because we're not really sharing or working with others right now, we hadn't done so yet. Could you go to the next slide, please? So to give you an example of what we did as part of the hardening process, we use a program called Gripe, which we've now automated fully into our CI/CD. And if you take a look at the TMS, the Transaction Monitoring Service API, before hardening, there were 2,209 packages, 72 vulnerabilities. After hardening, there were 36 packages and 0 vulnerabilities. That's a pretty complex service. There's a lot of things in there, but NiFi is actually really huge and uses a lot of different components. So before hardening, there were really only 347 packages, but there were 1,392 vulnerabilities in that particular container. Afterwards, after we hardened, we got down to 502, or excuse me, actually the packages went up. to 502. But if you notice, there's still 307 vulnerabilities left in there. Some of the subproducts that NiFi is comprised of, it's basically all Apache products. Those teams are not putting a priority on fixing some certain items. So they know there's deficiencies, but it's not on the radar map to get to yet. So all you can do in this case is know that those vulnerabilities are there and account for them and design around them. And that's basically what we've done in this case. So even after you're doing that, there can still be some vulnerabilities. Next slide.
Before we do, Greg, I just wanted to comment on the 502 packages from the 3 foot, because as a business person, I asked, well, okay, why has that gone up? No, stay on the one you were, Justice. So just for everyone's back to the previous one, the reason that the number went up from 347 to 502 was actually NiFi's interdependencies were actually complex. And the team actually broke them down to make them more manageable. So although there's 307 issues still in there, it was actually reduced because we created more controllable and more manageable packages. That's the reason for that going up. So, that was my first question. I liked the number that went on the first one, but didn't like the number on the second one. Which is why Greg's calling it out. But those are the reasons why, from a business perspective.
Greg, Frederick here. What's your risk acceptance procedure? If you have vulnerability like 300, how does that system go into production?
We need to work all that out. We're still very early days with all this stuff.
Okay.
But yeah, systems go into production with those vulnerabilities there. And we're going to have to pass on to everybody and probably put it in a container or in the system when it's deployed, infrastructure as code type, that all these dependencies are dealt with as far as mitigation. But some of the things are operational mitigation, that people are going to have to be aware of. But NiFi's critical.
Sorry, go on. Let's finish.
Yeah.
I was going to ask a quick question about how dependencies. Of course, many tools such as GitHub can show you dependencies. So as you create this software, how do you keep track of the different utilities and libraries and whatever it is to make sure that you're not importing insecure versions of those utilities?
Well, we'll show you actually, just as I can see you're plotting out the screen a little bit with what you've got. So we're going to show you basically a hardened container. The reality is we wound up building containers from the ground up. So we completely maintain control over what's going on. Not sure what's happening there, Justice. There we go. So if you look on the left, basically we started with a different container. You can see the parts that are highlighted. We're using Alpine because Alpine's a small Linux, but it came pre-existing with Node in the process. And we were also, we were just kind of accepting what's going on. So if you look to the right, actually it disappeared again, Justice. There we go.
Sorry, I'm having some screen issues at the moment.
No problem. I just want to make sure they can see it when I'm talking to it. As you notice, Node's been taken out. It's just Alpine. So we literally have done a ground up from this, and we're controlling every aspect of what goes in. And then we're going to have to build around those other dependencies as stated. But you can see just based on the script how the process goes. We then add in Node.js and npm ourselves and things like that. So the bottom line is and that actually took us a lot longer because we felt that we could not rely on other people's containers. And so I mean, this is a security system, right? It detects financial crime, and we've got to have that stuff right. So we went the extra mile and did those things. So these are all our clean containers. And that's really all I've got on that.
Cool. Thank you, Greg. Sorry, my screen is acting up. I've actually lost my main display on my laptop, and this is a bit of a challenge for me. So just bear with me. This is not ideal. So I'm quickly going to talk about our ISO 20022 changes. So we had originally implemented a very verbose message format. The ISO standard itself isn't very prescriptive about how the JSON should be formatted. They've issued a white paper on the topic. but it focuses more on establishing a JSON schema and then using the schema to represent the ISO message flow. And it didn't really suit what we were trying to do with the platform. So we ended up creating a JSON formatted message that uses the XML tags from the ISO standard instead of a more verbose description of the messages. This made it easier for us to create a repeatable process and also made the message itself a little bit more compact. So in terms of performance and in terms of being able to transmit that message more efficiently, we now have a much smaller message that we need to send through as part of our internal payloads and also as part of the message format in this platform itself as incoming messages. And then based on those changes, we refactored our ISO 20022.001 data pipeline. So all the way through from the transaction monitoring service itself, we completed that work. Data preparation in NiFi is complete, although the pseudonymization component of that is still in progress. The channel router and setup processor is currently in progress. Rule 3 processor, which is our template for all of our rule processors in the platform, that is complete. The typology processor is also complete. And then the two latest additions to our data pipeline, the channel aggregation and decisioning processor and the transaction aggregation and decisioning processors, those are still outstanding and will be completed in this current sprint, which is our first sprint for the PI. We replaced our gRPC intercept. Sorry.
Apologies to Jason. There was a question earlier on, but we waited for this moment. Leslie Ann was asking about the ISO 20022. That the current situation in terms of the ISO work, I think some of the thoughts there that the ISO comes as an XML, yet we need a JSON. Some of the data structures that Michael was talking to earlier were there, but I think in terms of the question, aligning the two streams, Justice has done a lot of work. So happy to have more meaningful discussions on the challenges we found so far. But for everyone's awareness, the front door for the Actio API is the TMS API, and that uses ISO 20022. So we convert that and push that through the environment. So we've done the conversion as if we've received ISO. The PPA discussion that's underway that a few of you may have seen converses bizarrely from Moduloop to ISO, so we can manage it. So it is worth having a conversation because we've seen the receiving side and the implications for the data stack for getting all the messages that we need. So happy to have that conversation.
Yeah, which also reminds me, Michael, you can please include me in your mail shot. Once you set up some sessions for the ISO 20022 discussions for Moduloop, I'd love to be a participant in those sessions. Thank you.
Yeah, it'd be great to have you, Justice. We will look forward to it.
Thanks, Michael. And then, as I mentioned earlier, we replaced gRPC with HTTP as our inter-services protocol, and that was more from a compatibility with OpenFAS. OpenFAS isn't able to access its high-scale functions if it receives a gRPC message and needs to be spoken to in HTTP. gRPC themselves have said that they have no intention to switch to gRPC, even though it is emerging in a more modern standard. So at the moment, we are using HTTP. But the option always for us in the future is to be able to accommodate either depending on how our architecture matures. And I'm going to hand back to you, Greg, for just an overview of our automated testing.
All right, so on the testing side of things, basically focused initially because we were still building out all the components that work together and we weren't doing a lot of detail. Yes, we had built out some typologies for testing purposes and things like that, but we weren't doing a lot of detail yet. But so it was pretty limited. Basically, we were making sure all the services were up and we weren't getting, the detail of response messages or anything that we can do to prove that a topology or a rule actually calculated what it was supposed to, did the appropriate thing. That as everything was pulled back together and aggregated together, that the appropriate decisions were being made. So what we focused on is basically how to do a shift left methodology, where the developers will be incorporating all that type of functionality into a lot of their code and into their processes. They're delivering things. So we've updated the process of design patterns to deliver much more. Excuse me, Siri's trying to talk to me.
I didn't get that.
Hate it when it does that. So it's a lot more verbose, and we get the messaging information back that we need for testing purposes. The response messages also include the outgoing message payload, because we do need to know that that's working correctly. So the incoming message, then there's a message that comes back, or there's more detail that comes back from that process, as well as then we append the outgoing message information to that process as well. Next slide. So we've been refactoring the existing processors to update the messages. TMS is complete, data preparation is complete, the channel router and setup processor is complete. Rule 003, which is the primary rule we test with and build around, because it encompasses everything, which you'll see in a second. Is still in process. The typology processor, channel aggregation, decisioning, transaction aggregation, decisioning, et cetera, is still in process. So this is something that we're working on actively right now. Next slide. So all in all, we've added 82 testing scenarios to evaluate the processor execution. And basically, we need to be able to test specific functions and the outputs of those functions. So to the TMS service, the transaction monitoring service, we've added 6 scenarios, 5 scenarios as far as the data preparation and NiFi, 3 scenarios for the channel router and setup processor. But as you can see, there's 46 scenarios that were added to the 003 processor for that particular rule. It covers a lot of different components, so it gives us a lot of coverage there. That one's in process. The topology processor, channel aggregation, those things are all in process and have multiple scenarios. The typology is also pretty complex. There's 16 scenarios there and 2 scenarios in the channel aggregation. And then in the final transaction decisioning process, there's 4. So, next slide. And that's back to you.
Thanks, Greg. So that would conclude all of the work that we did in PI4. As you can see, some of those things are still in progress, and we'll be bringing them forward into PI5 to complete. We aim to have our end-to-end with all of the automated testing and then all of the refactoring of the ISO 20022 message in the compact JSON format complete within the next couple of sprints. And then from then, we're focusing mostly on the content. The one key component that we still want to deliver early on in our process from a functionality perspective is the entity resolution. Entity resolution is something that masks our private data in the messaging, and we need to do that before we start building the rules. Otherwise, we'll have to rebuild all of those rules again once the entity resolution is done. So we have spec'd out our entity resolution approach. We have done some proofs of concept internally around specifically name matching and how we can achieve that, because that would be one of the key drivers of entity resolution within a modular context specifically. Not ideal, but it is the information that we have on hand at the moment. So between the date of birth, the identification information related to the root finding in the account lookup service, like MSISDN, or maybe even a personal ID or a passport number or an alias or something like that. And then also the name of the customer. Those are the 3 components that we have available in the current modular message. So we'll be using those to try and uniquely identify that customer across the ecosystem. And that's something that we need to do early, and we'll be doing that in our next sprint, so sprint 2. And after that, the rest of this PI will largely be focused on the content, which we call all of the rules and the typologies. So we'll be start building those out. If you have been keeping track of our overall timelines, we are working towards an ultimate delivery of an MVP that contains all of the content and the functionality that we need to offer a functional financial crime risk management system, or not management, but transaction monitoring solution. It's at the end of April. So we have about 6 months of work left to deliver quite a number of things still. But I think we're at the point now where if we are starting to cookie cut our content onto the platform, then we're in the home stretch as far as our solution delivery is concerned. And then I just quickly want to ask you, are there any questions related to the transaction monitoring service in Actio?
Sorry, Justice. Greg mentioned automated testing.
Yes.
In some of the slides. What tools are you using for that?
Automated testing is largely facilitated through Postman. So we run Postman simulates almost a service that feeds data into one of our processors and then also evaluates the data coming out of our processors. At the moment, it results largely in black box testing from our perspective, so we can only evaluate the output of the services, and it's also why we push the output back to the calling processor, because that's the direction that Postman is approaching the processor from. But our testing is largely through Postman.
Okay, last one then. Do you do any security misuse cases? I mean, Greg mentioned the hack with that malware. Do you do any misuse cases? Because financial systems are quite interesting to hack. So when you do the testing, you do misuse cases?
No, not for what we're doing here. So internally to the platform, we're testing mostly the functionality and the flows. We do have our platform itself secured in theory at the front door. So very specific endpoints. I don't know, Greg, if you want to weigh in perhaps a little bit more about how the platform is secured around the platform. But at some point, what we would need to do is extensive penetration testing, I suppose. But our MVP doesn't focus specifically on the exceptions that you might be looking for to try and find a chink in our armor just yet. But penetration testing, at least to be able to make sure that our platform is secure enough to go into a production environment, is essential. Greg? Yeah,
the misuse of the system is it's going to be more in the operational guides, and it's definitely not really in the focus. The scope right now is to get it's a brand new concept of how to run an engine. Basically, we've built a new engine that we're pretty proud of and nobody's seen before. But we've got security built into everything at the clustering layers. You know, obviously, if a port is open or an exploit is open, those are the things that we didn't have, you know, from an IFI standpoint, because we hadn't gotten there yet. But the whole thing basically is opaque. The one thing that we would like to have and add to the system at the moment would be using, we have a problem with this for a graph database. Being able to encrypt and storage that's a gap that we have, but we have thought of all this stuff, you know, basically all the way through, you know, but we're going to have to work all that out. I mean, this is a journey, and we've as Justice just said, there's still 6 months to go. So yeah, we could use advice on anything that we need to be looking for and what we need to do, but we feel we've got a very secure infrastructure. But you have a port open or you have an exploit open, that's, you know, everything's out the window at that point.
Yeah. So one of the things that we also focused on specifically to secure the data within the platform is the pseudonymization. And the platform itself is mostly around evaluating that information and then pushing that information out to a alert system or a case management solution. The operational control of the platform is probably something that would be added in greater detail after the MVP. So initially, we're just proposing to put the platform down and provide the initial sort of golden path functionality. But exceptions and extensions will definitely have to be added after the MVP is landed. And then a lot of the operational control that you would be looking for would then be built in those extensions as well.
Well, and to be clear, it's following the same approach that Modular did. You know, we're building an engine, we're building the APIs, we're building a system that can run. We're not building the UX to go around it or anything like that. So that's not part of our function and scope. Now, we know lots of people that intend to use it and do that. You know, Cybern wants to do that. LexDego wants to do that. You know, we will wrap that with our own solutions and you know, our own case management tools and things like that, because investigations are not just cases. There's a lot more to them than that. So there's a lot of work yet to go. By the time we're done with the MVP, it's going to be an engine that is mostly that'll run that is mostly worked with by API.
Great. Thank you for the question. Any other questions? I'll take that as a no, and then just quickly want to head into something else that we want to do. So I think Leslie Ann asked me a week ago if there was anything that we could do where we could involve the community a little bit better in the work and the thought leadership that we are putting around the financial crime solution and the work that we are doing with the community to bring Actio to life. And we thought that it might be useful if you're a fintech startup. You're focused on building your tech, you're focused on standing up your product, and you want to land your solution as soon as you possibly can. But what about the compliance things that you need to consider? There's data protection, fraud detection, customer onboarding, participant monitoring, money laundering, transaction limit reporting, all of a number of things that you don't want to discover when it's already 6 months down the line and the regulator is breathing down your neck. So what we would like to do is to host a workshop with the community to talk about the ABCs of compliance from a startup perspective. So under Chatham House rules, a workshop to discuss the things you wished you knew when you started out. And the kind of people that we want to involve, that we would like to talk with, and is business owners who are managing compliance aspects of their implementations at the moment, with Rwanda, Mali, or with Myanmar, or advisors for fintechs who are dealing with the fallout of weak or missing compliance at the inception of your solution. So you've built your solution, you deployed it, and a year later, you realize that there were a number of things that you should have put into it because the regulators are asking for it now. The outcomes that we're hoping for here is a community white paper that we could play back to the Mojaloop community and then becomes part of the community's body of knowledge to record the shareable lessons. So it does involve a little bit of opening yourself up to the embarrassing stories from your inception days, perhaps, that you haven't really told anybody yet. But hopefully you'll be able to share some things with us that we could share with other people to stop them from falling into the same pitfalls.
For those who haven't got stories, I've got more than enough that can bore people. And the part of this, Justice said, I'm not allowed to join this workshop because I have way too many stories and way too many things to talk about. So I'm not allowed to come with my experience. So please do support him. And Chatham House rules applies. But if you do, if that does apply, then, and I am allowed to attend, I will share a few to get things started, just to help you.
So somebody always has to go first, Rob, and then the floodgates of shame will open. So you're more than welcome to join us. And one of the other things that we're also looking for is a checklist of things that you might want to consider right from the start as an organization starting out. If, for example, you're implementing a Mojaloop switch or a small Mojaloop platform, what are things that other people have learned about compliance in the environment that you're going to be operating in that you need to think about right now? And then there are a number of things, if you're building a solution, perhaps, or a fintech platform, what are the essentials that you absolutely have to deliver alongside your minimum viable product to make sure that you are set up for success when it comes to compliance? If you'd like to join us, please save the date, 24th of November. We'll be sending out invitations. If you would like to join us, please contact me. My email address is on there, justice@lextago.com. And please come one, come all. We'd love to chat with you and discuss your experiences around fintech, startup, and compliance. Thank you very much.
Yeah, thanks, Justice. I think this really, augurs too well with the work that we are busy doing as a contribution to the community. There, we are building, the list of the controls and the processes that are required for, and the checklist and preventive actions what are required for a fintech company to deploy in order for them to not suffer the financial crimes and to reduce the financial crime from that side as well. So we were planning similar thing as well, and but somehow the fraud community was almost non-functional, and I'll be very happy if in case we can start to collaborate again and start to synergize these things, and that can really help the whole community.
Great. Thank you very much, Sudhir. And anybody else who's interested, please send me an email. Thank you. Greg?
Yeah, no, I was going to say all you have to do is look at, South Africa is a pretty advanced when it comes to money laundering and everything else. And as far as their processes, just take a look at the FATF report that they do on the countries that just came out for South Africa. It reads like a horror list. So trust me, there's a lot of problems all over the place. All we're doing is trying to get a handle on it. So definitely, as Rob said, don't be afraid to share. If you read that list, you know that there's a lot of other people with problems out there. It's crazy. I just went through it yesterday. It's unreal.
And thank you. That's us. Thank you very much for your time. Simeon, back to you.